Okay, vertical agriculture on a budget, right? I don't really want to buy other people's systems. I think that there are some good systems out there. I think that they are, for me personally, some of them are a little costly for very little output, and I don't know. When I was with my former business partner, I think we accomplished quite a bit by just repurposing old things, visiting construction sites and just things that we would find or broken things that we would fix or whatever, you know. So earlier I put out a video or a few videos that showed how I took a microcontroller like this and I put it on my network to control an LED. Okay, so the purpose behind that step was, so I wouldn't burn out things that I actually would have to purchase at greater cost, like this switch here. Okay, so this is a dual switch. Each one of these blocks here is a switch, and so I will have my power input. It'll be like high voltage control, or higher can be high voltage control, but with low voltage connectivity to the microcontroller. Now, in the last video, I was turning on and off an LED light just to see if I could go ahead and control it. And the purpose of that was to make sure that the code was right so that it could control this dual switch mechanism here, right? Okay, so, and I mentioned that I was going to be looking at a vertical planting system just as a prototype, just to test the theory that I would be able to take the tanks. All right, so I've got the 20-gallon tank that I learned on. I've got the Nitrobacter Nitrosonoma tank starting here. I don't know if any of you saw the video, but you remember this tank had that algae bloom in it. It was horrible, horrible algae bloom. Finally got that under control here. So this tank is now in good shape. And then you'll remember that I had the 60-gallon tank that originally I was going to get the perch in. Yeah, I know I got the whole school motif thing going on there. It's my thing. I can't help myself. So the idea is to integrate the ability to grow like tilapia or perch or freshwater prawn or mud bugs, whatever. Okay, be able to essentially clean water farm them, transfer the water to a grow system, but we have to make sure that we get it down to like safe ammonia levels and things of that nature, which takes place essentially in a system like this. With this, will grow the microorganisms that will convert the ammonia. And of course, then the next thing is to come up with a solid waste removal as well here. I probably won't video that. That's kind of gross, but still has to be done. But we'll convert the waste byproduct to a beneficial food source for the plants, right? Now, the long-term goal is to turn this into a expandable system, right? All broke down, modular, etc., etc. I've got a ways to go for that, and hopefully eventually a team to get that going. This is getting to be quite a bit to do on my own in my tiny little apartment. Anyway, so this is going to be the first test run on an indoor grow system at a size that kind of fits my initial idea for the for this particular phase of the business model, right? So I've purchased the PVC here. I have my pump. It's just a little micro pump. I just kind of want to see what it'll do. It'll probably burn out pretty quick. Just a small pump, but again, just prototyping. But if I have to, I can use a motor, kind of like this here, okay, and use this here to fashion an impeller, right? And so these will basically hop onto the front of the motor, this impeller idea that I came across. And it should just give me a bit more torque and be able to push, water higher, because, you know, pushing fluid through a small confined space up vertically, right? And so I've got this post here. Now this is just a little 4-foot section or 5-foot section of PVC that'll be fashioned to the receptacle here, this bucket. You know, then I'll fill the reservoir. I'll tie the reservoir in to the Nitrobacter nitrosonoma system here. And then also with lighting. So I've got to be able to move water, and I've got to be able to control light, right? And that's where these two components come in. But I've also got to I scalped this off of an old, I think that came out of an old broken PlayStation, and this came out of an old broken laptop. But a couple of fans here to, you know, kind of keep this internal water kind of moving and circulating. I'll get a bubbler in there to keep the water oxygenated properly. I'll have the switch to control lighting, fan, and water transfer. So that's kind of where I am now. I don't know if I'll be able to get this motor. This is actually an AC motor, so I've got to be able to remove this transformer to essentially convert this motor to run on DC rather than AC. Right now, this here is, creates an alternating current for this motor to run on, and I should be able to get this motor, once I take one of the coils out of here. There should be 2 coils in here, 2 copper coils, operating at different frequencies, and thus an alternating current, I guess, in a kind of a layman's little term there. But again, you know, this is low budget stuff, so I just kind of have to learn what I have to learn and do what I have to do to get this up and running and prototyped, you know, as low voltage as possible. So I'm going to try to get this below 12 volts, so I, you know, don't have to worry about like a bunch of, you know, fire hazard and whatnot. And I can prototype and test this off of batteries rather than plugging it into my wall sockets and worrying about starting a fire, you know. So I am trying to be safety conscious, especially of my neighbors, since I do, you know, live in a shared community. But this is kind of where I am now. From the videos that were seen before, this is my next little step, and you know, we'll kind of go from there. All right, okay.